Good morning everyone. In computer graphics, the very important topic is line drawing algorithms. We are going to see a small explanation about our line drawing algorithms. This is my agenda. First I am going to tell about primitive graphics objects, then line drawing algorithms, digital differential analyzer algorithm, that is DDA, limitations of DDA, and Bresenham line algorithms. Primitive graphics objects. Computer generated images are produced using primitive graphics objects such as points, straight lines and circles. These three play a vital role in creating an image in a computer. Line drawing. Many computer generated pictures are composed of straight line segments. A line segment is displayed by turning on a set of adjacent pixels. Pixel plays a very important role in a line drawing. In order to draw a line, it is necessary to determine which pixel lies nearest the line and provide the best approximation to the desired line. We have to finalize whether our next pixel lies nearest or downwards or the upwards or beyond our particular starting pixel. So that is very important here. The line drawing routine should be accurate, fast and easy to implement. Line drawing algorithms. A line in computer graphics is a portion of straight line that extends indefinitely in opposite direction. It is defined by its two endpoints. Its density should be independent of line length. The slope-intercept equation for a line is y equal to mx plus b, where m is the slope of the line and b is the y-intercept of a line. The two endpoints of a line are specified at the positions x1, y1 and x2, y2. Here is our starting point p1, that is x1, y1, and here is our ending point p2, x2, y2. We have to start with the x1, y1 and we have to plot a line till we reach the x2, y2. This is our goal. We can determine the value for slope m and b intercept as m equal to y2 minus y1 divided by x2 minus x1, that is m equal to delta y divided by delta x. This is the example. We had taken two endpoints of a line as 0, 0 and 6, 18 and we have to compute the values of the x here, y here. The solution is given below. The equation of the y line is y equal to mx plus b, that we already know. Now I am computing m with the values given above. M equal to y2 minus y1 divided by x2 minus x1. Our y2 is 18 minus 0 divided by 6 minus 0. It will come 3. So here we had declared m as 3. Next, the y-intercept b is found by plugging y1 and x1 into the equation. Y equal to 3x plus b. We are in the starting position, so our starting points are both 0, 0. So I am applying in the position of x and y 0. So I am applying here 0 equal to 3 into 0 plus b. Therefore we find out b equal to 0. So the equation for the line is y equal to 3x. The starting point at most we arrived. Our next challenge is to find a way to calculate the next x, y position by previous one as quickly as possible. We have to find it out. Next pixel is which one? The nearest pixel or upward pixel or downward pixels, and which pixels. For that only we are going for the line drawing algorithms. The most popular line drawing algorithm is our DDA algorithm. It is nothing but digital differential analyzer DDA algorithm. It is an incremental scan conversion method. It is an approach is characterized by performing calculations at each step using results from the preceding step. For example, incrementally we are reaching the starting point to the end point. For example, our starting point is 1 means our increment is also 1 means we have to calculate 1 plus 1 equal to 2. Then 2 plus 1 equal to 3. 3 plus 1 equal to 4. Like that we have to go till we reach the end point. This is our goal. This is the algorithm. We are having the two endpoints that we know, x1, y1 and x2, y2 are the endpoints, and dx and dy are the float variables, where dx equal to absolute of x2 minus x1 and dy equal to absolute of y2 minus y1. In the first step of algorithm, I am calculating whether the dx and dy is which one is greater. If dx is greater, I will plot the line towards the x-axis. If dy is greater, I will plot the line towards the y-axis. For that only the first step. If dx is greater than or equal to dy, then length equal to dx, else length equal to dy. Then end if. The second step, I am calculating dx equal to x2 minus x1 divided by length and dy equal to y2 minus y1 divided by length. In third step, I am having x equal to x1 plus 0.5 and y equal to y1 plus 0.5. In fourth step, I equal to 0. In fifth step, really I am plotting the x comma y. And the sixth step, I am putting the incremental, that is x equal to x plus dx and y equal to y plus dy. And in seventh step, I equal to, I am incrementing the integer float variable I equal to I plus 1. And then the eighth step, if I is less than length, then I will go to the step 5. Then in ninth step, it will stop the algorithm. I had given another example, that is 3, 2 and 4, 7 as the endpoints. I am showing the result here. You can check it out. Then now we are coming to the limitations of DDA. Okay, DDA is fast and accurate, everything is right. Then what are the limitations in DDA? One, why we are moving towards the another algorithm in line drawing? This is the answer here. The rounding operation and the floating point arithmetic are time consuming procedures. So we are going for the another algorithm. Then round off error can cause the calculator pixel position to drift away from the true line path for long line segment. If it drift away, our line, it will not be a straight line, it will be a congested line. So I will go for the another algorithm like Bresenham line algorithms. Thank you.